Let's jump right into this explainer because today we are uncovering the unexpected high stakes and, honestly, the ancient history of the world's most ordinary fruit. You probably have a bunch of bananas sitting on your kitchen counter right now, and we completely take for granted how they even got there. But behind that super familiar yellow peel, there is a really complex story of ancient domestication, some totally wild botanical anomalies, and a looming modern crisis that could literally wipe them out of existence. So we're going to cover the botany, the epic history, and the terrifying Cavendish crisis. Get this, right now, an astounding 99% of the bananas exported globally belong to just one single genetic cultivar. It's called the Cavendish. I mean, really think about that for a second. Whether you're grabbing a banana in New York, London, or Tokyo, you are essentially eating the exact same plant. The whole international export market relies entirely on this one specific variety. Now, sure, it provides incredible uniformity for shipping and ripening, which is obviously great for business. But as you'll see, it is a massive biological liability. It's basically a ticking time bomb. Ask yourselves, what exactly happens when a deadly global plague hits a food system with absolutely zero genetic diversity? Well, in nature, genetic variation is a species' main defense against disease. But when 99% of a crop is genetically identical, a pathogen that can take down one plant has the potential to kill every single plant on Earth. Part 1. Berries, Herbs, and Clones. Okay, so to truly grasp this modern crisis, we first kind of need to unlearn everything we think we know about what a banana actually is. The popular belief, it's almost entirely backward. We always call it a fruit tree, right? But the banana isn't a tree, and it's not a typical fruit at all. Botanically speaking, a banana is actually a berry because it develops from a single ovary and is fleshy all the way through. And the plant it grows on? It's a giant herbaceous plant. It's literally the largest plant on Earth without a woody stem. That so-called trunk you see is really just a tightly packed cluster of overlapping leaf sheaths. And here's the absolute kicker. The bananas we eat do not grow from seeds. They reproduce asexually through exact genetic cloning, transplanting cuttings or little offshoots from the parent plant's underground corn. And this beautifully illustrates why that whole cloning process is completely necessary for our food supply. If you stumbled across the banana's wild ancestors, species like Musa acuminata and Musa bilbasiana, you honestly probably wouldn't even try to eat them. They were practically inedible, just packed full of huge, rock-hard seeds. Our modern Cavendish, on the other hand, is actually a seedless, sterile mutant. Because it can't reproduce on its own using seeds, we have to step in and manually propagate it. Every single Cavendish banana plant out there is quite literally a clone of its parent. Part 2. A 10,000-year global journey. So how exactly did a hard-seeded wild plant become this sterile, cloned staple all over the world? Well, from its ancient agricultural roots in New Guinea to its super luxurious U.S. debut, the banana has literally followed the paths of global human conquest and trade. We're talking 8,000 BCE here. Archaeological evidence points to the Cook Valley in Papua New Guinea as the very first known site of banana domestication. And from there, the idea spread like wildfire. By 327 BCE, Alexander the Great discovers the fruit in the valleys of India. Fast forward to 650 AD, and Islamic conquerors and Arab merchants are carrying it into Palestine and across Africa. And then, jumping all the way to 1876, the banana makes this grand, flashy entrance into the U.S. at the Philadelphia Centennial Exhibition. Back then, get this, it was considered an exotic luxury, wrapped in tin foil and sold for 10 cents apiece, which is roughly $1.70 today, for a single banana. Even the word itself carries the weight of all that history. The word banana is believed to be derived from the West African wolof or Temne word banana, which was then picked up by Spanish and Portuguese sailors. Or another theory connects it to the Arabic word banan, which simply translates to finger. And honestly, that makes perfect visual sense when you realize that in the banana trade, a large cluster of the fruit is officially called a hand, and the individual fruits are, you guessed it, called fingers. Today, the production scale is just staggering, but it's super important to understand where they all actually go. For instance, while India leads global volume, producing almost 17 million metric tons back in 2005, that massive yield is kept almost entirely for their own domestic consumption. It acts as a totally crucial food security buffer. And it's the exact same story for Brazil and China. But Ecuador? Now that's a different story. With nearly 6 million metric tons, Ecuador dominates the international export market. They are the primary engines supplying our supermarkets with that 99% Cavendish clone we talked about earlier. Part 3. The Fall of Gros Michel. Now here's where things get wild, because our massive modern export market wasn't originally built on the Cavendish at all. Actually, up into the 1950s, the Gros Michel was the undisputed king of export bananas. It was supposedly a way tastier variety, it was firmer, it didn't bruise easily on ships, and it didn't even need those artificial ripening rooms we use today. It was basically the perfect export product. The Cavendish, at the time, that was just considered a second-rate backup. But history has a funny way of showing us exactly how fragile monocultures really are. You see, the Gros Michel relied on the exact same vulnerable genetic cloning system we use today, and that made it incredibly susceptible to Panama disease, a devastating soil fungus known as Fusarium wilt. This fungus would enter the roots of the banana plant and literally choke it to death, completely plugging up the flow of water and nutrients. The disease just spread unchecked. It completely wiped out commercial production of the Gros Michel by the 1950s. It was a total agricultural catastrophe. So to save the entire industry, producers were forced to pivot entirely to the Cavendish cultivar. And again, not because it tasted better, but simply because, at the time, it happened to be naturally resistant to that specific strain of Panama disease. Part 4. Saving the Cavendish. And this is where history is repeating itself right before our eyes. The Cavendish's immunity? Yeah, it didn't last forever. A reinvigorated strain of the fungus, called Tropical Race 4, or TR4, has emerged, and it attacks the Cavendish through the exact same lethal steps. First, the soil-borne fungus enters the plant right through its root system. Next, it moves up at the water into that false trunk, the pseudostem. Then it plugs the whole vascular system with gels and gums, completely cutting off the flow of water and vital nutrients. And finally, it causes the plant to wilt, starve, and die from the inside out. And because all Cavendish plants are identical clones, there is absolutely zero natural resistance. Once TR4 hits a plantation, the crop is doomed. TR4 was discovered in Asia back in the 1990s, and it has already wiped out Cavendish crops across several Southeast Asian countries. But here is the truly scary part. Because this fungus lives in the dirt, it can hitch a ride on something as simple as a farmer's muddy boot, a tractor tire, or just an unwashed tool. Because of this, TR4 is migrating incredibly fast. It's moving globally, and it is now actively threatening the entire Latin American export supply. If it takes hold there in full force, the supermarket banana as we know it could literally disappear. So scientists and farmers are now desperately racing against the clock. On the ground, plantations are implementing these incredibly strict quarantine and soil management protocols to just try and stop the spread. But on the defensive side, researchers are scrambling to either save the Cavendish or find its successor. They're working on developing new TR4-resistant cultivars through traditional crossbreeding, hoping to find a banana that survives the fungus but can also survive a long trip in a shipping container. They're also exploring advanced genetic engineering to modify the Cavendish itself. But honestly, the ultimate long-term solution has to involve ending a reliance on a single clone global supply. We have to embrace diverse export plantings so that a single disease can never threaten the whole system like this again. I want to leave you with this final, provocative thought to ponder. If we fail to stop TR4, and the supermarket banana actually disappears in the next 10 to 15 years, how will we rethink our vulnerable global food monocultures? The banana is a stark warning. If we can lose the world's most popular fruit simply because we demanded total uniformity, what does that mean for the rest of our perfectly engineered yet incredibly fragile global food supply? Thank you for exploring this with me. Keep asking questions and keep learning.